Let's try to prove the product rule from first principles. Well, our y in this case is uv, product of two functions. Our y plus delta y, so that's this height of the graph up here, is u of x plus delta x times v of x plus delta x. But I need to stick to the same notation that I introduced a minute ago. Instead of u of x, v of x, I just wrote uv. So what I'm going to do here is write u plus a little bit of u to represent that u of x plus a little bit of x, and similarly v plus a little bit of v to represent the function v evaluated a little bit further on than the original x. So it just means I don't have to bother with putting of x in this thing here. So this is u plus delta u, v plus delta v, which if we expand it out is uv plus v delta u plus u delta v plus delta u delta v. And you might be thinking to yourself, oh my goodness, I can see the product rule already. Okay, taking y off each side, y is uv, so this y here cancels with this uv and just leaves us with v delta u plus u delta v plus delta u delta v. Little bit of u, little bit of v. Okay, now we need to divide everything by delta x. V delta u by delta x plus u delta v by delta x plus delta u by delta x delta v. Doesn't really matter which of these two you've got on the top and which one's at the side. Now, going to take the limit as delta x goes to naught, and I'll just remind you of the rules that I have assumed I can use. The limit of two functions times together is the limit of the first one times the limit of the second one. The limit of two things added up is the limit of the first one plus the limit of the second one, and the limit of something that's got nothing to do with whatever it is, like the x that's going somewhere. So if this has got nothing, this alpha's got nothing to do with x, all of these are x going somewhere and they're functions of x. This is equal to alpha and then the limit of the f. So basically I can pull out anything that isn't anything to do with the thing that's going somewhere. So I'm just going to use these rules without proving them. Okay, where was I? Okay, so first of all, I've got a limit of a load of things adding up, but I've decided that, well, I haven't decided, I'm using the rule that the limit of these things added up is the limits of the individual things added up. So I can do the limit of this, the limit of this, the limit of this separately. And then here I've got something nothing to do with delta x times something to do with delta x, and also here something nothing to do with delta x times something to do with delta x. Okay, here I'm not sure whether that's got something to do with delta x or not. I mean this hasn't definitely and this hasn't definitely, because what they are is these two functions evaluated at that x value. So they're definitely nothing to do with this delta x. So what does that give me? That gives me v times the limit as delta x tends to naught of delta u over delta v, x plus u times the limit as delta x tends to naught of delta v over delta x plus the limit as delta x tends to naught of delta u over delta x times the limit as delta x tends to naught of delta v. Now some of this is really obvious. What bits are obvious? We've got obvious bit here. This is by definition du by dx. We've got an obvious bit here, which is by definition dv by dx, and we've got an obvious bit here, which is by definition du by dx. And then we've got this weird bit at the end that we're going to have to think about a tiny bit, this bit here. Now, if we imagine a graph just of the function v, so nothing to do with the product uv, just the function y equals v of x, and we imagine changing x a little bit, this much delta x, and then we measure how much v changes. delta v. Now what would happen as we shrink that delta x in and in and in and in towards 0? Well, you can see straight away that this is going to come down and down and down and down. So as I make the delta x smaller, the delta v is going to get smaller. So I'm not looking at a gradient here, I'm literally just saying what happens to delta v. And it's pretty obvious that if I make this tiny, 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 then the delta v will also be tiny, tiny, tiny. So actually, this bit at the end, as delta x goes to 0, what happens to delta v is that it also goes to 0. And then when you times these two together, you've got du by dx but times 0. So this bit equals 0. And what we're left with is the product rule.